that is a change. So what is the kind of strategy we need to bring in to build a structure which is 46 months when someone has built in 10 years? So that is something challenging. And you see Spring Temple Buddha, the location wise, you will see only Buddha statue. Apart from that, there is no other items for people to enjoy. Now we are also doing Chhatrapati Shivaji statue. We started, unfortunately there are certain issues, so we just stopped it. So we are very hopeful that it will come up again soon. Certain few project milestones. So we started these projects in December 2014, and we took around 13 months for design and 33 months for construction. The foundation was cast for the statue in December 2015, and it took 2 years for us to construct the concrete course. 2016 and 17, we completed the concrete course in 2017 December. And then after that, we were left out only 10 months to do complete steel erection and the bronze erection. So this is, unfortunately this light doesn't work here. So this is a typical location. So where the project site is located 3 kilometers downstream of the dam, Sardar Sarovar Dam. So when you go to this location, you can see the dam. And presently it is it's full of water. All the gates are open. If you go now, it's one of the most beautiful location to see now. Now you can see full of water in the river. Now the site is located inside the river, around 300 meters from the bank. So we have to construct a approaching bridge, and then over the hill we have to construct the statue. So this is on the left side we have the hill where the statue, and then connecting bridge, and on the banks we have other facilities, infrastructure facilities. Now this particular slide will tell you the story of various components of the statue. We have the concrete course. The concrete course will stop somewhere at this level. Above this is completely structural steel. The challenge is that you take concrete cores through the legs, and then each concrete core we need to accommodate one high-speed lift which is carrying around 24 passengers, and along with one staircase. So we have each concrete core, one staircase and one lift. Now we need to put that within the cross section of the leg, so that the cross section of the leg is the most vulnerable location of the entire statue. So that is the location where the entire moment has to be transferred, because it's a cantilever structure. Now this was a vision by Modi when he was Chief Minister of Gujarat government. In 2013 it started, and then it took a long time for tendering process, and then finally we got the job in 2014. And when we started this, and this picture actually gives how the location looks like. The hill, the small hill on the center is actually the site. And the picture on the left side is the dam when during that time there were no gates installed, and it is like a weir. And the right side one is current dam where all the gates are installed, and now you can see the water flow through the gates. And the first thing what we had to do is cut the hill and make proper approaches and reach 52-meter level where the foundation is supposed to be. We were asked to design the project for 15,000 visitors a day, and 2,000 visitors who can go to the viewing gallery level, which is at the chest level, 135 meters above the bridge level. And then I don't say earthquake resistant and all, these are all standard, but we have designed the structure for 180 km/h wind speed, whereas the actual wind at that particular region is only 39 meters per second. We designed for 50 meters, but we have been asked to design for 50 meters per second, which is 70% higher. So this actually created a lot of challenges in the design. So this is how the location looks like. You can see the dam on the towards the back side. And when you are traveling towards the statue, you will first see the backside of the statue, because the statue is always looking towards the dam, and the idea was that a visitor should not see the face directly. The visitor has to see slowly, then when he comes in the forward direction and then see the face. The original idea is you get down 5 kilometers before the statue site and get into the river, take a boat, travel through the boat for 5 kilometers and take a turn in the front and then get down, and then that time you see the face. That is the actual proposal. Now the navigation part is still not commenced. So Gujarat government is now making that dredging portion along the river. Now once that dredging is over, probably the water level will be maintained throughout. And one pier is going to be constructed, which is getting completed, and then you will see water maintained at a constant level and navigation is possible. So this is we did a complete bathymetry survey, and then this is the topo of the site where the statue is going to sit. And when we started the excavation work, and the rock is very good. The good news is that rock is very good. We didn't require any piling, any other type of foundation. We had to simply go for an open foundation. And there were many questions asked about the foundation. Now, when we say 100 years design life, and we talked about, I told about the durability of concrete. Now, we had limitations in IS 456. Now, typically IS 456 recommendation is for a building which is 50 to 60 years life, but it doesn't talk about what are the requirements of what parameters are required to design a building for 100 years. It doesn't talk about it. Now, where should we go? Now, when this was asked, so what we did is we went to other courts to see where we can take reference from other courts to see where we will stand and what kind of inputs we can take. So one basic code which we have within India is IRS code for bridges. So that particular code talks about 100 years design life, and then British code 8500 also gives about 100 years design life. So these are the two codes which we had references, and these codes talk about what is the minimum cover you need to maintain and what is the minimum grade of concrete you need to provide for a particular item if you want to achieve that kind of durable concrete. Now this again depends on what kind of exposure condition and how your external environment is. Now the good part of this particular project is it is an excellent environment where there is no pollution, there are no industries around, so it's a moderate exposure condition. So finally we ended up doing 50 cover for each and every element, including slab. So that was the extent to which we had to go. Now, if we are not going to do this cover, then I need to go and change the reinforcement, maybe some other type of reinforcement, maybe stainless steel reinforcement or galvanized reinforcement or epoxy coated rebar. And there are so many areas where the people are not comfortable with epoxy rebar, issues with this, and stainless steel is obviously very expensive. So we need to find out one optimum solution where it is durable. I am able to give concrete which is 100 years life, and also it is cost effective. So we had finally come up with a compromise on the cover, and the grade of concrete was finally maintained minimum as M50. Even though certain location it was M40 was recommended, but M50 was maintained minimum for each and every element. Now, there was one peculiar thing which happened in this project is that the requirement from client is that since it is going to be a monumental structure, let us build factor of safety in the design. So if it is zone 3 as per architect code, so let us propose zone 4. So what is the reason? Yeah, this is an important structure, so let us go for higher factor of safety. Similarly, for wind, 39 meter per second. Instead of that, go for 50 meter per second. Again, factor of safety. Now, by doing this, what has happened is the the leg, which is the most vulnerable part, and the cross section has decided what actually is the capacity it has. Now, within the core, I have occupied certain space for lift and staircase, and outside, I cannot go beyond the line what the sculptor has drawn. So I have to maintain within that. Now, whatever thickness I am able to get for the wall, that is what I am having. So I cannot increase the thickness. Now, increasing the grade of concrete too much also doesn't help me. So we go on with M65 at this particular level. So when we did the wind tunnel test, we had very surprising results. That the structure is not able to transfer the load, the moments at the angle location for the force for which wind tunnel testing agency has given for 1.5% damping, internal damping. So 1.5% damping is taken for concrete as a inherent damping for concrete. So for that, whatever force was given, it was not sufficient. Then what is the next we can do? Then we asked consultants what we should do. Then they said we need to increase the damping. So finally we have proposed to increase the damping from 1.5% default internal to 4% damping, and by doing that we were able to reduce the force on the structure by around 30-35%, and we have provided finally tuned mass dampers, 2 numbers in the structure. So these are the tuned mass dampers which are provided on top of the concrete core above the chest level, on the top of the concrete core. Each TMD is weighing 200 metric tons. Now this is the second time in India we have installed tuned mass dampers. Anyone has installed a tuned mass damper. One was ATC Tower, Delhi, and second one is Sardar Vallabhbhai Patel statue. Now, there are so many challenges when you introduce something like this technology. There are so many questions asked by people. What is this? Why you are introducing this? How come the damping increases by 4%? How you would guarantee this? So these are certain challenges which you need to take and convince people that this is how it works, and bring institutions and then convey message that this is how. These are not a very new technology. These were done in US 40-50 years back. So these are all the things which we need to bring into industry, saying that how you can design optimum, how you can come up with optimum designs. If this TMD was not there, it would have been very, very difficult for us to design for that particular construction. Now, concrete is one, and when it comes to the steel, it's only to create the shape of the statue. So steel was used to create the shape of the statue, and to connect the bronze to the steel. So steel is basically used like a skeleton, and the entire steel is connected to concrete using embedded plates. We had a lot of challenges in fixing the embedded plates, and when we used the jump foam work. Now we had many issues. Now basically these are all the different concrete grades and steel grades used in the project. Now coming to the foundation. Foundation, in fact we took around 5 months to get approval of foundation for this project. The basic question people were asking is, how can this statue is standing on open foundation? So people, and that too there was no filling on we didn't have any filling on top of the foundation. So people had crazy questions that how it is standing like a pedestal, how it is not toppling. So there were so many why you are not anchoring. There were so many questions asked. The reason is that the load which is coming on from the statue is so high that you don't need any anchoring. And the kind of foundation what we have provided is 44 meter by 34 meter. It's huge. I think it is something like this hall, and 3 meter thick. Now when we did this 3 meter thick raft, again, how do you cast this raft, which is around 4,500 cubic meter? How do you cast this raft? How many joints you need? How do you do the post? Again, with a lot of discussions, we found that it is very, very difficult to manage with the joints. Very, very difficult to go with the stage-wise pouring. Go with single pour. Finally, the entire concreting was done in single pour.
Oh my God.
Continuously for around 6 days, 132 hours. It's continuously poured. Now, one serious challenge which we had to face is the temperature. We have been asked to pour the concrete at 25 degrees centigrade, and with another condition that the temperature should not go beyond 50 degrees. And there was no project where the temperature has been maintained, internal concrete temperature was maintained 50 degrees. When we said client and customer consultant that it is difficult to maintain 50 degrees, they said no, this is what is written in the document, so you need to maintain 50 degrees. Now, it is we know it is very difficult. So when we were checking the temperatures, what were all the precautionary measures L&T has done? So the water is actually supplied like a chilled water. So we have installed a chilled water plant. We supply chilled water instead of normal water. The entire aggregate was kept in ice, and then that aggregate was used in the concrete. It is basically to reduce the temperature and to so that it doesn't go beyond 50. But all these measures, it was not effective. It was still going to 65, close to 70 degrees. And then we had to call professors from IIT, whether this 70 degrees is okay, whether this 65 to 70 degrees range is okay, and also our consultants to see whether this is okay. And after a lot of deliberations, they accepted that okay, we will allow this temperature, but with one condition that there should not be thermal cracking happen. So, taking all these issues, so we had to manage that. We had to pour. Luckily, the entire foundation was poured in December, where the weather was very good. It is not very high like summer, 45 degrees and all. This particular place, winter is very, very comfortable. We will have 25 degrees. So continuously we could pour even in the daytime. These are a few photographs, and there was a huge inauguration before the pumping of concrete started. Chief Minister came and then he inaugurated, and then after that, I think it was 15th of December, I remember, 2015.
This is one column.
And then we had one more challenge of how do you access this particular hill. So the first thing what we did is we constructed a Bailey bridge, a temporary bridge, which we got it from China as a complete prefabricated, and then assembled, and then over that the trucks will go, and the entire pumping of concrete was done from the bridge.
Oh my God!
So that is the bridge. Now, if you go today, even today the bridge is still there. Recently, we have been told that client told not to dismantle this bridge, so they want to retain this bridge because this was actually supplied for a temporary period of 3-4 years. So they want to retain this as a secondary usage. So we don't know how many years it will stand. Now, what we have been given is a hill, which is having complex shape. Now we need to bring this to a shape where it looks like what you planned. Now there are so many challenges in this. So we had one particular area where this right bottom side, we had a huge structure coming there, the museum and exhibition hall. So we had to do a lot of filling in that area. So how do you do this filling? And that concrete, this entire concrete will be submerged in water because the 100-year flood level is much higher than this from the dam. So what we did is we constructed a bund wall, which is bund wall was M30 grade concrete, no reinforcement, nothing, just a bund wall. We constructed along the red line. We constructed a wall, huge bund wall, and the bottom cross section is around 10 meters and top around 2 meters, and in between that entire area was filled with CLSM. There's a controlled low strength material, CLSM, and over that the structure is sitting on isolated foundations. So we did a testing on that plate load test, and we were getting 40 tons per square meter. A lot of people don't use CLSM for structural purpose. We actually used CLSM fill, And when we did testing, we got 40 ton per square meter. Very, very comfortable, for which we designed the balance structure. And when we proposed this CLSM also, client was not comfortable. How can you fill this kind of material? How this will take the load? Whether if water comes from the dam, whether the entire thing will get washed out. These were the questions asked. So heat is one issue which we had to take this throughout the project. So we were only producing the report saying that 65 to 70 we are able to manage. Now this is the cross section of two cross sections. The left side cross section is a big drum, and then inside the drum we have two elliptical shaped core walls. That drum goes up to 25 meter height. So up to 25 meter height where the museum is there is very, very stiff, very, very stiff. And because the drum is again connected with the core walls, with the shear walls, intermediate shear walls, so it is very, very stiff. And suddenly above that, only the two elliptical core walls are going, which are very, very flexible now. And what we did at one point of time, what we thought is we can connect the two core walls with a coupling wall once the Dodi starts closing the statue. So that's where the connecting wall will actually come from somewhere from this level. So we actually used Arup. Actually, Arup has designed the structure. So I should not take any credit for design of the structure. So Arup is our primary consultant who designed the structure, and he made all the concept and then decision making in design. The entire structure was designed using 2D beam element. The entire foundation was designed using 2D grill edge beam element, and client consultant was not at all happy because everyone nowadays they do with the shell element, 3D solid elements. Now how come a person comes and design with a 2D beam element, a raft of 3 meter thick? No one was comfortable, and it took 3 months for us to convince client that whatever we have done it is correct from first principles. And not only the foundation, the entire structure is modeled using beam element. The entire core is just a beam element, one beam element, and the beam element is given the cross section of the core. So they used a software called AdSec. So in AdSec you feed the geometry of the core, you will get a complete cross section on all the properties, and then you feed that into the software. So this is the cross section of the core. The beauty of the design is you get the axial forces and the moments from the software. Now you take the core and put the reinforcement on whatever diameter you want, whatever spacing you want, and run the software and get the capacity. The AdSec will give you the capacity of the cross section. Now using this capacity, draw a graph. Now the horizontal and vertical is the blue color line is the capacity of the core, and all the dots are the various forces from the various combinations, load combinations. Now if all the load combination results are within the outer blue color line, that means the design is so robust that the core has adequate capacity for all conditions. This is how it is designed. Otherwise, it is not possible to design like how we will do. I go and check for each and every load combination and load case. That is not possible. So this is how the entire concrete design was done using AdSec. So even this concept also was not very, very easy to convince people. And later on then the jump form came into picture for core walls, and then you can see the entire structure coming out on the small hill. Now here we had one more challenge of as per the contract, the entire wall which is built, which is the retaining wall on the outside, it should look like a rock. Now we have one straightforward thing is you build a RCC wall and then outside you do some stone pitching sort of thing, but whether it will stand during water flow, that was the question. Now how do I prove? It's very difficult. So what are the other alternative solutions? Then what we found is a foam liner. So in the shuttering itself, I put the liner. It was imported from Germany and it has repetitions around 20 cycles. So you put the foam in the liner in the former and pour concrete, and when you remove, the left side is the shutter, in which once the liner is removed, you will see that form of the rock, and this entire these panels, right side panels, when you are seeing close look, you will see that it looks like a rock surface, and over which we did a painting. That's all we did. So we simply used a liner in the shutter, and then did the entire wall casting, and then we did a painting. Very, very simple. But liner is very, very expensive, but it is, since it is giving so many cycles, it is worth the cost. Otherwise it is very difficult for us to do look like mountain. Very difficult. One more challenge is then the hill is so small, you don't have space for any scaffolding, you don't have space for too many cranes. So that one crane was kept outside, which was connected to on the back side of the structure, and one crane was kept on the top of the right core. So these were the only two cranes we had for throughout the structure. And like that cycle, so initially the cycle time was around, the first cycle was 25 days. Then with some improvement it came to 20 days. But people wanted 10 days cycle. So from 20 days to 10 days you need to reduce. So how do you do? So then we had to see each and every parameter, each and every bar, how it is bent. But is there any other method where I can change the bar shape so that it can be easily inserted? Whether is there any method to put it like a cage? So like this, each and every core we have changed the sequence of the rebar placement and the embed placements, and then over period of cycles we could finally reduce it to 7 days. The last core was done with 7 days cycle. So there was huge embed plates which were coming. So this is the jump form. Perry has supplied the jump form. So this is how it looks. It's almost on the top of the structure now. So after this I will just take few slides on other elements of the statue. So this is how the statue looks like inside when you cut a cross section. So the steel is connected to concrete using embed plates. And these are all various structural steel elements, and we have a dedicated maintenance system inside the statue. We have series of walkways at various levels. We have staircases inside the statue. People can go in and then do maintenance, and then you can see whether the bolt is loosened, you want to do some painting, you want to clean something. Everything can be done. A dedicated system is given completely inside. So we had various challenges in aligning the core, and when we brought the steel, whether it is at that particular location, the desired location, a lot of challenges were there. So one option what we used is, so there may be some deviation in the core alignment. So the stuff which was welded to the concrete, it was not brought to the exact length what was shown in the short drawing. It was brought extra length, green length, and then based on the survey, if I had to cut 50 millimeters or 60 millimeters, it was cut at that location and then fixed, so that that correction was taken in steel, not in the concrete. So this is somewhere in June 2018.
Cloud.
Okay, this is a bronze panel. The panel which is on the truck is 5.5 meter height. Okay, why I have put this picture is on the left side. The picture is this is one more statue which Shakurji is building in Rajasthan. I think it's about to commission. It's about to open for public in a few months. It's a Seva statue in concrete, and you will see full scaffolding from bottom to top. Full scaffolding, and we have not used a single scaffolding material for the project. Only 2 double cranes. So that is a differentiator between these two projects. So we had 550 mega panels which we erected at the end of the day. So the picture, what you can see, the face is a 1:1 scale face which is assembled before it is dismantled and sent to site. It's a full face we have assembled and checked whether it is matching as per the sculptor requirement. These are all other aspects of the bronze, and here you can see the detailing aspect of the shawl. So the shawl is having the threading effect, so all the threads you can see. So even the front, the waistcoat is having the pattern of this texture. Even that is captured in the casting of the bronze. And this is about the viewing gallery. When you go to this viewing gallery, you can see through the gallery. When you are standing on the front side, you can see the dam. When you are on the back side, you can see the river. And also on the sides, we have given glass on the sides so that a person can experience how the statue will look inside. The complete experience is given at that particular floor. It is completely air-conditioned floor. There are so many challenges to create an air-conditioned environment inside that area. So this is how the gallery looks like inside. The panels looks like this. We have given actually some perforations in the panels deliberately. The reason is to take air inside and reduce the heat inside. Otherwise, there was too much of heat building inside because copper is very, very high in conductivity, so it heats up the air. So there are many locations where we have given perforations so that the air goes inside and then you get fresh air. And these are all slides on the bronze, how it is analyzed and integrated. And lightning. Lightning was one effect which was addressed in a very, very special manner. The entire lightning will transfer from the bronze to the steel, to the reinforcement, and then from the reinforcement is earth. That is one path. And second path is each and every bronze panel is again interconnected. Actually, the bronze panels are connected using sealant between the panels, which is having around 8 to 10 millimeter gap. So physically, there is a gap of 8 millimeter between the panels. To create continuity, we have again given a strip, copper strip between the panels, so that the entire skin behaves like a one unit, and when the lightning strikes, it is again taken to the ground. These are all about some logistics of bronze. So we have pre-assembled one particular slice of bronze at ground in the yard, and then with the steel, and then each panel is taken out along with the steel, and then it is taken for erection. So these are all the pre-assemblies. The panel height is around 5.5 meters. So this is the most complex level where the kurta is there. It's having a big fold like this. So this was done in inverted way. You could not do it in a regular way. So we have done this in an inverted way. Yeah, this is the waistcoat. The top left image, you can see the button. The waistcoat, the pattern is very, very beautiful. When you see from close, you will appreciate it. But right now, when you go and see, it's very far away. It will be very difficult unless you have a very powerful camera. You cannot see that texture. Certain images of face assembly. And the initial stage of erection of the panels and attached to concrete. From here, I will just take the photographs during various stages of the project. You can see on the right, somewhere there, you will see the patches like this. So that is the viewing gallery where you have the perforations. So when you go inside and you can see through that perforations. This is actually my very favorite slide where you can see the head skeleton, how it looks like. That resembles the face. This particular piece of erection was very, very challenging because all the nodes, steel nodes, were in air. You don't know where to put it. So unless you put it at the exact location, define that location, all other will go wrong. So defining that position and fixing is very, very challenging. And apart from that, we have in this project structural health monitoring. I think India will come up with this kind of structural health monitoring in future. So every client will ask for this. So one is how do you report the settlement of the foundation? Then how do you measure your deflections of the structure? Then how do you record your accelerations during an earthquake? And similarly, how do you measure strains in the concrete or axial shortening? So this kind of stuff you need to have specific instrumentation at specific locations, and then all these instruments are to be connected to a centralized monitoring system, to a computer, and then monitor the data continuously and study that whatever you have designed, whether the structure is behaving in that fashion or there are certain things which you need to correct. So that particular data will tell us what is happening, whether we are in the right track or certain corrections has to be done. This was the CFD analysis which we have done to see how much heat is building in. This is a 1:1 scale of the face before it was cast. So it is done in the foam model. All the corrections were taken at that particular stage, and the sculptor has gone several times to this place and then given corrections. And so how the both looks the same because the same panel is kept there. Asked few photographs of the construction stage. If you go and stand on the chapel, your man height is almost the height of the chapel. The chapel height is around 1.8 feet. Apart from this, we had a challenging task on protection of the bank. That entire area was actually filled up during the dam construction. It was a completely filled material, so which was built up over last 30-40 years by various contractors. They have filled there. So the challenge is how do you put a structure over there and protect that entire area. So we have built the slope protection from the bed level to the top. So that is around 25-meter height. We have done the protection work. Thank you.